Hello and welcome. H&B presenting the weighing indicator DAD 141.1. This video demonstrates how to set up the logic inputs and outputs by using the front panel buttons. The user interface. Front panel buttons, here setup operation. Up and down buttons, press one of them for 3 seconds or longer to start the setup menu. Select a menu item between 1 and 8. Select a submenu item to choose the parameter. Edit the selected parameter. Enter button. Enter the submenu item parameter. Quit submenu and save changes. Move right button. Select a display position in setup procedure for the parameter. Quit setup menu. Depending on the menu item, press once or more often. The logic input features. The DAD 141 has 2 isolated logic inputs. Menu 6, setup for the logic inputs. Submenu 6.0, setup for the logic input 0. Submenu 6.1, setup for the logic input 1. Each logic input can be assigned to one out of 16 different functions. Submenu 6.0.xx, function of the logic input 0. Submenu 6.1.xx, function of the logic input 1. The logic input functions. To set up in submenu 6.0.xx or 6.1.xx, examples. 00, factory default, no function. 01 acts as the 0 button. 02 acts as the tab button. 05 starts a triggered measurement, for example in a check-weigher application. 10, the display shows the last peak-to-peak value, etc. Example for a logic input setup. For the logic input 0, we choose function 10, display of peak-to-peak value, via submenu 6.0.10. Each time the input 0 sees an externally controlled high-level signal, plus 12 to plus 24 volt DC, the display will show the last peak-to-peak value. Submenu 6.0, logic input 0. Submenu 6.0.xx, select 6.0.10 by using the up and down buttons. Press enter to quit and save the changes. The logic output features. The DAD 141 has 3 isolated logic outputs. Menu 7, setup for the logic outputs. Submenu 7.0, setup for the logic output 0. 7.1, setup for the logic output 1. 7.2, setup for the logic output 2. Setup of the parameters 4. Set point, polarity, hysteresis. Each logic output can be assigned to 1 out of 9 different references. 1 for gross value, 2 for net value, 3 for peak value, 4 for average value, 8 for an error message, input signal too high, above 3.3 millivolt per volt, or a load cell connection failure, etc. The logic output setup. Submenu 7.0 for logic output 0 with 7.0.1 setup of set point 0. 7.0.1.1 setup value for set point 0. Value range plus minus 9999999. 7.0.1.2 setup of polarity for set point 0. Submenu 7.0.2, Setup hysteresis for set point 0, value range plus minus 9999. 7.0.3, set reference for set point 0, for example 1 gross, 2 net, 3 peak, etc. 7.0.4, test mode for set point 0, open, close the contacts by using the up and down buttons. 7.0.4.0, output is off. 7.0.4.1, output is on. Press Enter to quit and save the changes. Switching logic. The switching logic of the logic outputs will be defined by polarity and hysteresis. Polarity on or off, output status normally closed or open, and hysteresis positive or negative. The following table will show the output status depending on polarity setup, on-off, and the current weight value increasing, decreasing with respect to the defined set point in hysteresis. Example for output 1, switching logic. The table shows the output status. The set point is set to 2000 kilograms. The hysteresis is plus 500 kilograms. The polarity setup can be on or off. The current weight values increase or decrease in our examples. The output status for polarity 0, off, is shown in the left graph. The weight value increases from 0 up to 2000 kilograms. The output is closed. When the weight value becomes higher than 2000 kilograms, the output switches to open. When the weight value decreases to 1500 kilograms, no changes with the output status. If the weight value becomes smaller than 1500 kilograms, the output switches back to close. The right graph with polarity 1, on, shows the opposite switch logic behavior. Example for output 1, switching logic. The table shows the output status. The set point is set to 2000 kilograms. The hysteresis is minus 500 kilograms. The polarity setup can be on or off. The current weight values increase or decrease in our examples. The output status for polarity 0, off, is shown in the left graph. The weight value increases from 0 up to 2500 kilograms. The output is open. When the weight value becomes higher than 2500 kilograms, the output switches to close. When the weight value decreases to 2000 kilograms, no changes with the output status. If the weight value becomes smaller than 2000 kilograms, the output switches back to open. The right graph with polarity 1, on, shows the opposite switch logic behavior. Summary: the four graphs show the switch logic of the outputs depending on the setups of hysteresis and polarity. The blue area of each graph shows the influence of the plus or minus hysteresis. The hold time. Submenu 7.3, setup of the hold time. The value range is 0 to 65,000 milliseconds. This menu defines the hold time for all three logic outputs, set point limits. The load cell signal has to exceed the set point limit continuously for this time period before the corresponding output will be switched. Press Enter to quit and save the changes. To finish the logic input and output setup, press the Move Right button 2 or 3 times and the DAD will be back in weighing mode. Weighing indicator DAD 141.1. Many thanks for joining the training Logic Inputs and Outputs by using the front panel buttons. We would like to invite you to watch more training videos. For feedback or FAQs, just see our website hauback.com or send an email to info@hauback.com with your wishes, experience reports, questions or comments. Thanks and take care.